Last class we were discussing about image formation. I have one object and one mirror. What if I have more than one mirror? Okay, so that is images from multiple reflections. That's what it is called. Okay, let's say that I have two mirrors like this. You see, this is my first mirror here, first mirror. This is one second mirror. This is, let's say, M1, and this is M2, M1 and M2. Okay, makes sense. One object is kept here in between. This is my object. From this object, light rays will go in all directions, in all the infinitely possible directions. Okay, spherically it will spread. Okay, in 3 dimensions. Now, so some of those lights will hit M1, some of them will hit M2. Okay, so let's start with light which hits M1. Okay, let's say that one light hits M1 like this. Now what will happen to this light? It is hitting it normally. Okay, it is hitting it normally. Okay, so it will retrace. And if I take any other light like this, let's say this is the other light. Okay, one light is hitting normally, the other light is hitting at some angle. It will reflect like this here. Do you see this? Okay, now if I extend these two backwards, okay, they will appear to meet at a point here. Now what is this point? This is image. First image, okay? First image from M1. First image from M1. Okay, now these light rays, this will retrace and it will go to the other mirror like this here. Do you see this? Okay, what are these lights? These lights are lights that are reflected from first mirror. Now this mirror, what this mirror will think? You see, mirrors also have brains, if you bother to think about it. Okay, this mirror will think that these two lights are coming from a point here. There must be an object. There is something. Something is there. You see, mirror does not know whether it is a real object or imaginary object or virtual object, virtual image, whatever it is. The mirror has to bother only about the light. It is receiving some light, it has to reflect, that's it. What it will think is that these two light rays are coming from this point here, so there is an object here. What actually is happening is that the image from the first mirror, it becomes an object for the second mirror. For this mirror, this is an object. Okay, now it will reflect light, image will be created. Okay, this is my normal here, light will reflect here like this. This is how the light is going to reflect. Okay, this is how the light is going to reflect at some angle here. Do you see this? Do you see this? Now, if I extend these two reflected lights, okay, if I extend these two reflected lights, okay, so I think this angle has to be a little more. Okay, a little more angle. Otherwise, they seem to be diverging. I want them converging. Okay. So I am going to make some change in my diagram here. This is my first mirror like this here. Okay, and if I extend these two backwards, okay, you see, do not worry too much about the diagram. It may not actually be accurate, but you see, it drives home the point I want to make. Okay. If I extend it backward like this, okay, so this becomes my second image. What is this? This is image of image. This is image of image. This is my object. The light starts from, the light hits here, M1. Image I1 is created. The reflected light hit M2. These are light reflected from the first mirror. They hit M2. Okay. This mirror will think that there is an object here. Okay. So this image from M1 becomes an object for M2. Okay, so this will create an image. What is this? This I2 is image of this. This is image of image. Okay, now this mirror again. Now these light rays, they will hit M1 again. Okay, now M1 will think, this mirror M1 will think that these two light rays are coming from this point. There is something. Okay, so now this image becomes an object for M1. First mirror, okay, and then it will create an image. It will create an image, okay, like this. And if I extend these two light rays, okay, they are going to meet somewhere here. This becomes I3. Now this I3 will be at same distance behind the mirror as this I2 is. If this is D, this is going to be D. Okay, do you see this? So what is happening? Light ray is getting reflected several times, multiple reflections. After each reflection, image is created. Okay, so we are going to get many number of images that will depend on the angle between mirrors. That will depend on the angle between this mirror. Okay, so we have one general formula. We have one general formula for that. Okay, so let me write that formula, you remember those formulas, and then if you get direct questions, you can solve it. Apply the formula, you get the answer. Okay. Now it's like this. Number of images. Number of images. Okay. From two mirrors inclined at theta. Theta is angle between these two mirrors, M1 and M2. How do I find the number of images? The first step is step 1. Calculate 360 over theta. 360 over theta. Okay. Step 2. Okay, now 360 over theta. When I calculate that, okay, this is going to be either an integer or a non-integer. Only two possibilities. Of course, it is going to be positive. When I calculate this thing, 360 over theta, it is going to be either an integer, 1, 2, 3, 4, 5, or a non-integer. Okay. If it is an integer, it is going to be either an even number or an odd number. An even or odd. Now, if it is even, in that case, number of images, it becomes 360 over theta minus 1. Okay. Now, if it is odd, then we have two more options. Okay. Now, what are two options? Object at bisector. Okay, not at bisector. If the object is at bisector, then number of images is going to be equal to 360 over theta minus 1. Okay. And if it is not at bisector, the number of images is going to be equal to 360 over theta. Okay, that's it. That's it. What is the meaning of bisector? What is the meaning of bisector? Okay, let's understand it through some examples. Simple examples, very simple ones. Okay, find number of images. Very simple ones. Okay, first case. I have this angle here. These are two mirrors. Two mirrors. It is kept inclined at 60 degree, and object is here between the mirrors. What is number of images? Okay. Second, this is M1 and M2. M1 and M2. Let's say that this is 72 degree. 72 degree. And my object is kept here. This is my object. And this angle is 36 degree. Okay? You understand this? And then third, okay, the same mirror, same inclination. This angle is 72 degree, and the object is here. This is my object. Okay, let's say that this angle is 20 degree. Okay, just for example, 20 degree. In each case, how many images we are going to get? Okay, so let's apply this algorithm. This is kind of an algorithm. Okay. Non-integer, we will see. Discussing about integer only. Okay. What is 360 over theta? Is going to be equal to 360 over 60. It is going to be equal to 6. Now this is an even integer. Okay. So it comes into this category. Okay. Integer, it is even. So, number of images, it is going to be equal to 360 over theta minus 1. This is going to be 5. Okay, here, 360 over theta is 360 over 72. This becomes 5. This is an odd integer. Now, in odd integer, we have two more options. Okay, object at bisector, not at bisector. This object here is kept exactly between the mirrors. Exactly between the mirrors. That is the meaning of bisector. 72, 36. This object is at bisector. Okay. Then number of images. Okay. Object at bisector. Number of images 360 over theta minus 1. This becomes 4. I will get 4 images. What about this? Okay, this here will be 360 over theta. This will be 5 here. Why this happens? It happens because if the object is symmetrically placed, then two images will form at the same place. Two images will form at the same place. They will coincide. Two images coincide. That's why it's minus 1 here also. In such cases, when I have an even integer, then two images are going to coincide somewhere. Okay, and that's why I have minus 1 here. Now, what about non-integer? Let's say I get 5.2, I get 5.5, 5.6. Not integer, non-integer. In that case, use graphical method. Now, what is graphical method? Okay, there is no standard formula for this. Okay, keep in mind. Some books give formula, but that is erroneous. It is not correct. Keep that thing in mind. Some books give formula for this also. That works in some cases and they do not work in some cases. They fail miserably. Okay, so that is erroneous. That is not reliable. Okay, so keep that thing in mind. They are not reliable at all. Let's understand the graphical method, and that is a very beautiful method. Okay, very beautiful, excellent method. It's like this. It works like this. Okay, we are going to make use of what we discussed in the beginning in this lecture, and properties of image, especially the object distance and image distance. Let's say that I have this mirror here. I have these two mirrors. This is M1 and this is M2. Okay. What we have to do is we have to actually count it. We can actually count the number of images. That is the meaning of graphical method or counting method. Counting. Graphical is it may not be appropriate because we are not really going to draw a graph. We are going to count the images. Let's see how. Let's say that my object is somewhere here. My object is here. This is my object. We know that multiple images are formed because of multiple successive reflection. A light ray starts from object, it hits M1, then it goes to M2, then it goes to M1, again M2. The light ray is successively reflected between both mirrors. It keeps on bouncing between both mirrors. After each bounce, an image is created. Okay. Let's start with M1. Let's start with M1. Okay. Object distance. This is the object distance. Okay. The image will be formed on this normal line at same distance behind it. Same distance behind it. Okay. If this is D1, this also is D1. Okay. It is a normal. This is normal. We are normal. This becomes my first image. Multiple images are formed because of successive reflection. This is image from M1. This image acts, it becomes an object for the second mirror. This image becomes an object for the second mirror. Okay. So where will be the image? So I just have to draw a perpendicular here. Okay, the image of this is going to be at same distance behind the mirror. This is going to be well I2. Image from M1. This acts as an object for M2. M1, M2. Next term is for M1. Now this is going to act as an object for M1. Okay, so what we'll do is I will just extend my mirror, extend this mirror. Now this is going to act like an object for M1. Okay, so one image will be formed here at same distance behind it. At same distance behind this. This is I3. I3. Now the next term is of M2. Now will there be an image? There will be an image as long as it is in front of mirror. Okay. Now if I extend it backward like this, okay, this image falls behind the mirror. Behind the mirror. There will be image as long as it is in front of mirror. If it is not in front of mirror, then the image formation stops. It stops. So we started with M1. We got three images, I1, I2, I3. Now next, I will start from M2. Okay, but because the light ray we will hit M2 also directly. Okay, so I will get one direct image. This is one direct image from M2. Okay, this will become my I4. I4. Direct image from M2. Now this is in front of mirror M1. This becomes an object for M1. So there will be an image at same distance behind the mirror. What is this? The distances must be same. Okay? Roughly. Not roughly exactly. They must exactly be same. Why roughly? Exactly same. This is I5. Now this is in front of M2. Next image will be from M2. This is from M1. Next will be from M2. Okay. Right. Same distance behind the mirror. Same distance. Exactly same distance. I6. How many images? Now, next term is of M1. This image is from M2. Next term, because there it gets successively reflected. M1, M2, M1, M2, M1, M2. Okay, it will alternate between M1 and M2. M2, M1. Next term is M1. But now this is behind M1. That's it. So there is no further image. So I am going to get 6 images. 6 images. Okay? Total 6 images. Okay? Now, a very interesting property. If this is D1, this also is D1. This is D2, this also is D2. Do you understand this? Okay. This is the intersection of mirror. Intersection of mirror. Okay? This distance from here to here, if I call this distance R, distance of object from the intersection, if I am calling it R, what will be this distance from this intersection to this first image? Okay, will it not be same? This is D1, this is D1. Angles are same. This side is common. Two sides are same, common, not common. Two sides are same length. Angles, this angle is same as this angle. These two triangles are going to be similar. Okay. Angles are same. Okay. So this distance is also going to be same. If this is R, this also is R. Not only that, this is R. What about this length? This distance. This side is common now. This side is common. This side is equal to this. This angle is same, 90-90. These two sides are also going to be same. Do you see this? And then you can extend your logic. You see, look at this here. This distance and this distance. They are also going to be R. If this is R, this also is going to be R. Okay. What do we see? What do we see? Okay. You see, I4 and I5. I can compare these two, I4 and I5. If this is R, this also is R. Okay. So you can continue this logic, and then now there is no need of continuing anymore. What it means? You got the idea. Every image, object and every image, all of them are on a circle. Every object, every image plus the object, all of them are going to be on a circle. Okay, it's like this. They are going to be on the circle. You can just join them with a circle like this. The object and all the images are going to be on a circle. A beautiful thing. Okay, I'm just making some adjustment because you see, I have not drawn this perfectly anyway, but it drives home the point. Okay, absolutely. Remember this. Okay, that's how we can count it. All right, let's do some problems. Then we are going to move on to some other concept. Okay, few simple problems. Okay, let's look at a few simple problems. Locate all images. X and Y, these are actually mirrors. These are actually mirrors, okay? And I have one object which is kept here. Okay, I have an object which is kept here. Let's say it is 1 and 2. 1 and 2. This is my object. So there will be many images. You just have to find their coordinates, locate them. Okay, an object is kept between two parallel mirrors M1 and 2 as shown. Okay, here I have, there are two parallel mirrors. This is M1 and M2. Okay, I have an object here. This is my object O. What are the distances? Okay, let's say that this is 5 centimeter and this is 10 centimeter. Okay, distance between the mirrors is 50 centimeter. How many images will be formed? Okay, now taking first reflection from M1, taking first reflection from M1, okay, find distance of third successive image from M1 and M2. Okay, not on the problem. It should not be difficult to solve. It should not be difficult. Okay, pause the video, try to get the answer in your first attempt, and then let's discuss it. How many images? 360 over theta is 360 over 90. Is x-axis, y-axis. Angle is 90. This is equal to 3. This is an integer. This is 4. It is an integer. So number of images will be even integer. So 360 over theta minus 1. This becomes 3. Okay? Makes sense? There will be 3 images. Now where they will be, I can actually use that graphical method to find out. I can use the graphical method to find out. Okay, let's see how. This is M1, let's say. This is M2. Okay. Here is my object. This is my object. Okay. Let's start with M1. Let's start with M1. This is the first image. This is my first image. This is I1. This distance will be 2, so this will also be 2. Okay, so what will be its coordinate? It will be 1 and minus 2. This is 1, 2 here. Okay, that means this distance is 1. The coordinate of this image will be 1 minus 2. Okay, it's pretty much obvious. This is image from first mirror. Now this becomes an object for M2, for second mirror, and this will form an image, okay, at same distance behind the mirror. This becomes I2. I2. Distance will be same. If this is 1, this also is going to be 1. So what will be coordinate? Okay, it will become minus 1 and minus 2. This is from M1, M2. Next term is for M1, but this falls behind the mirror. So there is no further image. We have to stop here. Now, next we will start from M2. Okay, starting from M2, I get the first image here. This is the first direct image from M2. Let me call it I3. Okay, this distance is 1. This will also be 1. This distance is 2. Okay, this distance is 2. So this is also going to be 2. What will be its coordinate? Minus 1 and 2. Minus 1 and 2. Image from M2. This becomes an object for M1. Okay, so there will be an image. Okay. What is this distance? This distance is 2. So I will get an image, same distance behind the mirror. Now when I do that, the image coincides here. Okay, so I2 and I4 both coincide. That's why total count is only 3, I1, I2, I3. Second and fourth image have coincided at one point. They have coincided, that's it. Okay, so I will see only 3 images. Okay, that's how we do it. Okay, all of them will be on circle. Okay, now we can understand it this way. The object is kept between these 2 mirrors. Okay, one image each behind the mirror. One image behind this mirror, second image behind this mirror, and the third image will be along this, on this diagonally opposite side here. Okay, so between 2 mirrors, one image each behind both mirrors and one diagonally in between them. We will get 3 images. Okay, now the next one. How many images? What is theta? 0 degree. They are parallel. What is number of images? There will be infinite number of images. Number of images will be infinite. Okay, n will be infinite here. Okay, theta is 0. Number of images will be infinite. Okay, how do they form? We can understand it very simply like this. How do they form? They form like this. I have these 2 mirrors. Let's say that I have an object here. This is my object. Okay, light starts from the first mirror M1, M2. Okay, it hits the mirror and then it retraces. It goes back to the other mirror. Okay. If I take any other light ray, it goes like this. Now these 2 reflected light, they form an image somewhere on this line at same distance behind it here. This becomes my I1. Okay. Now these 2, this is reflected ray, this also is reflected ray. Okay. They will go and hit the other mirror. Now for this mirror, this becomes an object. Okay. So it will form an image same distance behind the mirror. Okay. So the object is going to be on the same line here. It is going to be on the same line. Okay. So this is going to be reflected like this. Okay. And if I place it back, this becomes I2. Okay. Now the light will rebound from here, and here it will reflect and hit the first mirror. Now for this mirror, this becomes an object. Okay. And again the light will be reflected. This is known as successive reflection. Successive, and then I am going to get an image. So this becomes an object. This becomes an object for the first mirror. Okay, I am going to get an image same distance behind the mirror like this. All of the images are going to be on this line, which is the common normal, including the object. Common normal from the object. All the images are going to be on this line only. Okay, so this becomes my I3. This process will continue, and I am going to get infinite images. Infinite. Okay. Now, so what we have to do is starting from taking first reflection from M1. So we started from M1. So this is first image. First image, second image, third image. I have to find the distance of this image from M1 and M2. What will be the answer? What will be the answer? Okay, let's solve it quickly. Okay, 5 and 10 centimeters. Okay, we can do it this way. First image from M1. First image from M1. Okay, so this is my mirror. Okay, let me draw it like this. This is M1 and M2. Okay, we just discussed that all the images are going to be on this line, which is the common normal from the object. Okay, common normal from the object. It's pretty much simple. The moment you draw, you locate all the images, immediately you get the answer. My object is here. Here is my object. Okay. Okay, let me write it at M1 here and M2 here. M1 and M2. Okay. Now what will be distances? First image from M1. I am going to get my image here at the same distance. This becomes I1. This is object I1. These distances are going to be 5 centimeter and 5 centimeter. 5 and 5. Okay. Now this becomes an object for second mirror. What will be object distance? This is the object distance. What it will be? This distance from here to here. This is 15 centimeter. 15 plus 5, it becomes 20. Image will be same distance behind the mirror. Okay. I am going to get my image at the same distance here behind it. Okay. This is going to be my I2. First image, second image. This distance is going to be 20. Okay. Now, this becomes an object for this mirror. What will be object distance from here to here? This is 20 and this is 15. This becomes 35 centimeter. So this becomes an object for this. Object distance is 35. Image will be same distance behind the mirror. Okay. 35 centimeter. It's like here. I3. This is going to be 35. This is 35 centimeter. Answer. Distance from M1 is 35. Distance from M1 35. What will be distance from M2? This distance from here to here. This is going to be 35 plus 15, 50 centimeter. That's how we do it. In books you find formulas for this. Better not to rely on those formulas. Okay. You can apply your own head, I am sure about that. If you are able to understand all of this, then you can derive your own formulas also. Do not be dependent. Somebody derived it, congratulate him, and that's it. Okay. Do not try looking formulas for every cases. Okay? Do you understand this point? Okay. Okay, now the last thing in plane mirrors is a very important point, that is velocity of image. Velocity of image. A very important one. Let's say that I have this mirror. Okay. Mirror time. In front of this there is one object here. This is my object. Okay. It is kept at some distance. Let's say that this distance is t. This distance is t. At this instant, it is going to have its image here. It is going to have its image here. At same distance behind here. Okay. Do you understand this? You understand it? Okay. We are going to discuss several cases. Okay. You have to do it patiently. Then we will derive one formula, and using that formula we are going to solve few problems. Okay. Let's say that object is moving parallel to mirror. This is V1. This is velocity of object. Let's say this is velocity of object. Object is moving parallel to the mirror. Okay. Object moving parallel to mirror. Parallel to mirror. Okay. It has velocity VO. Parallel to mirror. Okay. Understand this. So in some time it will travel some distance. Its position is going to change. Let's say that it reaches here. It reaches this point O dash. Its velocity is VO. Okay. In some time it reaches this point. Now what is this distance? This distance will be equal to VO times t. This is x. VO times t. Okay. Now, object reaches here, where will be image? Image will also change. If object reaches here, okay, the distance remains same. It is moving parallel to the mirror. So this distance is going to be same. The image will be at same distance behind the mirror. This becomes I dash. Now what will be this distance? From geometry, simple geometry, it's obvious that this distance is going to be x. This is x. Now let me say it is x1, this is x2, this is velocity of image. It is going to be equal to velocity of image times t. Okay. From geometry, x1 is equal to x2. That means velocity of image is velocity of object. That's it. As simple as that. Remember it. Okay. So if I have this mirror, in front of mirror, my object is moving parallel to the mirror. Parallel to the mirror. Then whatever is the velocity of object, image is going to have same velocity. Same velocity. Okay? Understood? Now, object moving normal to mirror. Normal to mirror. Okay. In that case, this is my object. This is my object, let's say. This is my object here. Object is O. Okay. At this instant, okay, its image will be same distance behind it. This will be my image. Object and image. Okay. This distance from here to here and from here to here, it is d. It is d. Object has certain velocity. Let's say it is equal to VO. After some time, it moves some distance. Okay. Object reaches from this point to this point. So image will also change because image distance is always going to be object distance. Okay. Image will reach this point here. This is I dash. Okay. Now, if this distance is equal to x, okay, then what will be this distance? Simple geometry. This is x. Then this remaining distance is going to be d minus x. Okay. Then here also this distance is going to be equal to d minus x. That means this is x. Both are moving same distances. Both are moving same distances, but in opposite directions. Object is moving towards right. Image is moving towards left. Okay. So normal to the mirror, velocity of image is going to be equal to minus of velocity of object. Okay, velocity of image is going to be equal to velocity of object, and both of these are with respect to mirror. With respect to mirror. Okay. Here we did not say anything about the mirror. Whether the mirror is at rest or moving. Remember this. Note it down. Both of these are with respect to mirror. Okay? The mirror may be at rest or it may be moving. All these velocities are with respect to mirror. Okay? So in general, let's derive it. Okay? So not let's say that I have this mirror here. This is the mirror. Okay. This is my object velocity. Okay. This is the object velocity. So if I have an object moving at some angle, okay, what we will do is, okay, we will break this velocity into two components. Okay, let's say this is V normal, this is V1, let's say, and this is V2. This is V2. So if object is moving at some angle, in that case I will break that angle in two components. One component is normal to the mirror, the other component will be perpendicular to the mirror. Then for the image, the parallel component is going to be same. This is my image. So this is going to be same. And the component which is normal to the mirror is going to be reversed. It is going to be reversed. Okay? And if I join both, okay. So if object is moving in this direction, image will move in this direction. This is velocity of the image. Okay? Do you understand this? We are joining these two. You get this. Okay. Now let me write one general formula and then we are going to solve it. Few problems. Okay, general formula. General relation, let me write it. Okay, parallel to mirror. Parallel to mirror. Okay, parallel to mirror. Velocity of image with respect to mirror is equal to velocity of object with respect to mirror. Going to be same. Okay. Now normal to mirror. Normal is perpendicular. Normal to mirror. Okay. Velocity of image with respect to mirror. Okay. Is going to be minus of velocity of object with respect to mirror. Do you see this? Now, okay, I can rearrange this to find velocity with respect to ground. Okay. Try to recall the relative motion. This is equal to velocity of image with respect to ground minus velocity of mirror with respect to ground. Do you see this? Is equal to minus of velocity of object with respect to ground minus velocity of mirror with respect to ground. Okay, now this I can rearrange. Velocity of image with respect to ground. Okay, is equal to. If I take it on the other side, this is minus, this will become plus. It becomes 2 times of velocity of mirror with respect to ground minus velocity of object with respect to ground. Okay. If mirror at rest, then velocity of image with respect to ground is minus of velocity of object with respect to ground. Okay, I can convert this also similarly. Parallel to the mirror. Parallel to the mirror. Okay, I can also do it same. Okay, velocity of image with respect to ground minus velocity of mirror with respect to ground. Okay, is going to be equal to velocity of object with respect to ground minus velocity of mirror with respect to ground. Okay, these things cancel. That means it is always velocity of image with respect to ground is velocity of. Okay, so this relation holds, but this is only parallel to the mirror. This is normal to the mirror. Okay, let's do few problems. Let's make use of this. Let's see how to apply this. Let's see how to apply this. Okay, and then we will find the velocity. Question. What is velocity of image? Okay, first case. I have this mirror. This is object, let's say it is 2 meters per second. 2. This is 3 meters per second. Okay, and this is, let's say, 5 meters per second object. It is moving perpendicular to the mirror. Okay, third case. Let's say that this is in this direction here. It is 4 meters per second. 4 meters per second, and this is moving in this direction here. This is, let's say, 2 meters per second. Okay, object and mirror. And then fourth one. Okay, fourth case. I have this case here. Let's do all these cases. Okay, I have this, let's say, 10 meters per second. 10 meters per second, and then it is moving at some angle here. Okay, this angle is, let's say, 37 degree. 37 degree. Okay, and mirror is moving with some velocity, let's say 4 meters per second. 4 meters per second. what is going to be the velocity of image? When we say velocity of image, that means velocity of image with respect to ground. Okay. Let's make use of this formula. Okay, and then try to answer all of this. Okay, let me give you one hint. Both relations, vector quantities are involved. Vector quantities. Okay, so I have to be careful about the direction also. You can use I, J and K, but that is not required. It is not required. Okay, what we can do is I can make use of positive and negative sign. Okay, so let's take velocity towards right as positive, towards left negative. Okay, upward positive, downward negative. I can make use of this direction. Okay, positive and negative. Instead of writing I, J and K, I can make use of positive and negative sign. Okay, it's all the same. It makes no difference. It's just a matter of choice. Okay. Now parallel to mirror. Parallel to mirror. Okay. Velocity of image with respect to ground, with respect to mirror, is equal to velocity of object with respect to mirror and velocity of image with respect to ground is velocity of object with respect to ground. We just derived it. Okay. Now normal to mirror. Okay. Velocity of image with respect to mirror is minus of velocity of object with respect to mirror and velocity of image with respect to ground. This is what we have to find. 2 times of velocity of mirror with respect to ground minus velocity of object with respect to ground. Something I have to remember. Okay? Standard formula. Okay. Make use of this. Get the answer. Velocity is vector quantity. I have to be careful about direction also. In the first case, let's solve it then and there. This is already, okay. First case, it is already normal. First case, normal case. It is normal case. Normal case means perpendicular case. Okay. Velocity of image with respect to ground is equal to 2 times of 0. Mirror is not moving. Minus velocity of object. What is velocity of object? It is plus 2. It becomes minus 2 meter per second. This is simple. Velocity of image. Okay. That means image will be moving like this. 2 meter per second with respect to ground. Second is also normal case. Okay, this also is a normal case. Velocity of image with respect to ground 2 times velocity of mirror. This is velocity of mirror. It is towards right. I will write plus 3 minus velocity of object. It is towards right. This also is plus. What do I get? Plus 6 minus 5. I get plus 1 meter per second. Okay. That means in this case, image will be moving in this direction. This will be my image. This object, image, it will be 1 meter per second. Towards right. Okay. Do you see? Third case. This also is a normal case. Okay. Velocity of image with respect to ground. 2 times of velocity of mirror. What it is? 2 meter per second. 2 times of minus 2. 2 times of minus 2 minus velocity of object. It is minus 4. What do I get? Minus 4 plus 4. 0. Image will not move. Very interesting case. The image does not change. It remains at rest. It does not move. Okay. Now the fourth case, okay. So I have both components in the fourth case. Okay, the fourth case is like this. Fourth case, okay. So in such cases, I have to resolve it in two directions. One velocity will be normal parallel to this plane mirror, 37 degree. This is going to be 6 meter per second. Okay, this is 6 meter per second, and this component is going to be 8 meter per second. 8 meter per second. Okay, this mirror is moving with 4 meter per second here. 4 meter per second. Okay. Now image will be somewhere here at the same distance. This is my image. Parallel to the mirror, this is my mirror. Parallel to the mirror, the velocity is same. Whatever is velocity here, okay, image is going to have same velocity parallel to the mirror. Okay, so this is going to be same. This is going to be 6 meter per second. Okay, normal to mirror. Normal to mirror. Velocity of image with respect to mirror, not mirror but ground I want to find. 2 times of velocity of mirror. It is towards right. Towards right is positive. Plus 4 minus velocity of object. This also is towards right. This is plus 8. That's it. Okay, it will depend on the values. Okay, it can have any value, whatever, any value. This is how the image will move. Okay, so that's it about plane mirrors. Okay, next class we are going to start spherical mirrors.